Here, concepts relating to the manipulation or transformation of the algorithm's output are introduced. In order to compose more powerful trading systems, Trading Conceiver lets you manipulate the output of the algorithms. This is enabled through checkboxes. The usefulness and examples of this will be explained later. Now focus on the concept and above all what happens in the case of intervals and intraday trading. If multiple checkboxes are selected, the manipulations are applied in the order they appear in the checkboxes: not, step, extend. The logical NOT operator negates its input. It's also called complement. True becomes false and vice versa. For the Boolean value at open and close, this is straightforward. True becomes false and false becomes true. In order to see that, let's select the same algorithm in two different slots. In one of them, let's activate the NOT operator. We select any operator between the algorithms. Run the simulation. In the table, we can see the straight algorithm and its complement. Where the straight algorithm is true, its complement is false and vice versa. If we want to see the same thing in the charts, let's select the long 1 and long 2 indicators. Run the simulation again. Now in the chart we can see the two algorithms, the straight one and its complement. Where one of them is 0, the other one is 1 and vice versa. For the value and interval at threshold, things get trickier. Negation is performed by complementing the interval. Then the Boolean value is set to true if the complement of the interval is not empty. It is set to false otherwise. So the Boolean value is not simply the negated of itself, like in open and close. The Boolean value simply says if there is at least one value between low and high where the algorithm is true. Let's suppose we have the following values: low, threshold, high. Here is a list of intervals with the corresponding Boolean values before and after applying the NOT logical operator. For the interval low threshold, the Boolean value is true. The complement of the interval is threshold high, which is not the empty set, so the Boolean value is true. For the interval threshold high, the Boolean value is true. Its complement is low threshold, and not being the empty set, the Boolean value is true. For the interval low-high, the Boolean value is true. Its complement is the empty set, so the Boolean value is false. If an algorithm is false throughout the interval low-high, it means that it's true in the empty set. Its complement is the universe low-high, so the Boolean value is true. In order to see that, let's proceed as before, but this time let's select an algorithm operating intradaily. After running the simulation, in the table you can see that where the straight algorithm is always true, throughout the interval low-high, Boolean value true, its complement is always false, Boolean value false. Where the straight algorithm is true in the interval threshold high, Boolean value true, its complement is true in the interval low threshold, Boolean value true. Where the straight algorithm is always false throughout the interval low-high, Boolean value false, its complement is always true throughout the universe interval low-high, Boolean value true. You can see the same thing in the chart. Often, but not always, for a given elementary algorithm, it already exists another elementary algorithm, which is its complement, that is, the algorithm obtained by applying the NOT operator. For example, angle of MA of stochastic positive, angle of MA of stochastic negative. These are the NOT of each other. So in theory, these are equivalent. NOT applied to the angle of MA of stochastic positive and angle of MA of stochastic negative. However, the second version is faster because it is calculated directly, whilst the first one is calculated in its straight form first and then negated. The negation is what renders it slower. So always prefer the straight version of an algorithm if it exists to a NOT version. More accurately, these two expressions are not equivalent because they check for strict inequality, strictly greater than and strictly less than respectively. Therefore, when the angle is exactly 0, both these algorithms are false, and consequently these two algorithms differ. Being both false, not false is true, and this is false. That's a mathematical difference that doesn't change anything, though, because in the real world it is an inane distinction. Besides, we could have legitimately defined the algorithms checking for a non-strict inequality as well. Singularities like this get cancelled out even at threshold when dealing with intervals, because intervals are always considered closed. Indeed, we can simplify things considering the intervals always closed and never open, because in the real world that is an irrelevant distinction. The step manipulation detects where an algorithm transitions from false to true. After applying the step, the resulting algorithm is true only where the original algorithm toggles from false to true. So, if we select the same algorithm in two slots and apply the step operator to one of them, after running the simulation, we have both the straight algorithm and the algorithm after applying the step operator. When the straight algorithm transitions from false to true, the step function is true. If the algorithm is defined only at close, then only the Boolean values at close are compared. In this case, the step can be present only at close. If on the contrary, the algorithm is defined intradaily, then the Boolean value at close is compared with the Boolean value at threshold. The Boolean value at threshold is compared with the Boolean value at open. The Boolean value at open is compared with the Boolean value at close of the previous bar. In this case, the step can be present at open, threshold, and close. The extend functionality is used to make a trading system operating only at close to operate also intradaily. Most of the indicators found in literature are calculated using the closing price, so they are well known at the close instant in time. What happens from open to close? Both the following are legitimate assumptions. From open to close, the indicator is not defined, so it doesn't exist. From open to close, the indicator takes on the same value as the preceding close. The first assumption is straightforward. The second implies that once calculated, the indicator keeps the same value until it is updated. As updates are made at close, this means that at next open and throughout the next day, it will maintain the value of the previous close. This difference is irrelevant when dealing with indicators per se, but is pivotal for trading algorithms derived from indicators or not. In order to build a real trading system, algorithms must be combined together. This means that their outputs must be compared, and based on their reciprocal values, a new output is built. The combination occurs for each of the 6 steps of the composer and is performed through logical operators like OR and AND. Suppose you have in the same tab of the composer 2 algorithms, one valid only at close and the other valid throughout the day. How do you combine them intradaily? As both these assumptions are sound, we allow both. By default, the assumption that from open to close the indicator is not defined holds, so it doesn't exist intradaily. In this case, when combined with another algorithm operating intradaily, the combination will be valid only at close, while during the day it will not be computed. If you want to opt for the other assumption, that is, that from open to close the indicator takes on the same value as the preceding close, you must apply the extend manipulation option. It copies the Boolean value at close to the next open and threshold. The name comes from the fact that we extend the close value to be valid to the next bar until the next close. In this case, when combined with another algorithm operating intradaily, the combination will be valid and computed not only at close but throughout the day. The extend option copies the Boolean value of the previous clause to the current threshold phase. The extended Boolean value holds for the entire intradaily duration of time, whatever its range of price values is. Therefore, if the Boolean value was false at close, a threshold the extended algorithm is always false. Or put another way, the interval where the extended algorithm is true is the empty set. If the Boolean value was true, the interval where the extended algorithm is true is the universe interval at threshold, low, high.